Okay, so this is, we're now in section 4.4, all right? So which deals with quadratic modeling. So this is section 4.4, quadratic modeling. All right. So in this problem, what it wants us to do is it wants to maximize the revenue. So if you think about any company, right? Your goal is always how do we increase our profits, right? How do we make more money. Okay. So in this case, it says the marketing department at Texas Instruments has found that when certain calculators are sold at a price of P dollars per unit, the number of X calculators sold is given by the demand equation. A, find a model that expresses the revenue R as a function of the price of P. B, what is the domain of R? C, what unit price should be used to maximize revenue? D, if this price is charged, what is the maximum revenue? E, how many units are sold at this price? F, graph it. And G, what price should Texas Instrument charge to collect at least $675,000 in revenue? Okay, so first let's attack the first part here. I'm going to minimize this so I can maximize my area of writing. Okay. So it says find a model that expresses the revenue R as a function of the price P. All right, so here's my A. Okay. And so I need to do this, I'm going to need the formula R is equal to X times P. R is equal to X times P. Okay. So I already know what X is. X is given by this. So we're just going to take this here, demand equation, and multiply it by P. Okay? Because we want a quadratic. Right? So right now this is linear. We want a quadratic. So we take the 21,000. Again, sorry I'm writing small, but I need all the space I can get. 21,000 minus 150 P. And then I'm going to multiply that. That's our X, right? This here is X. So we're going to multiply that by P. Okay. Then we're going to distribute the P. Okay. So when we do that, um, we're going to get 21,000 minus, sorry, 21,000 P minus 150 P squared. All right. So this is going to be our function of R, not R of X, but R of P. Okay. So this is the equation that they want. Now I'm going to rewrite this, okay? Because I want the leading term to be the p square. So I'm going to rewrite this as R of p equals negative 150 p squared plus 21,000 p. Okay? All right. Okay, so it says find a model. This is a model. Model just means deduct an equation based off the information that they give you. Okay, so it says find a model that expresses the revenue R as a function of the price P. That's what we have. We have it in terms of P. Okay, so there's our answer right there for part A. Okay, so now let's work on part B. Part B says, okay, what is the domain of R? Okay, so the domain of R is going to be coming from part A. We're going to set that because it's already in factored form and set that equal to 0. Okay, so we're going to get part A and set it equal to 0. So we have 21,000 minus 150 P, and we'll set that equal to 0. And then we also have P is equal to 0, right? So again, it's coming from these guys. Okay? That's what I'm doing. All right, so when we solve for P on the left, okay, due to space here, I'm going to get 140. Okay? So when I solve for P here on the left, we're going to get 140. And the other point we have is P equals 0. Okay? So if we were to draw that, so let's go ahead and draw our coordinate plane. Okay, so we'll have, let me pause here for a second. Okay, sorry, that's a terrible drawing there, but it's really hard to draw on this tablet. Okay, so we found our, we need to, again, part B wants us to find a domain. So we found our x-intercepts, right? So we want positive profit, so we don't really care anything about below. We want everything on the quadrant one because that's what tells us our revenue. Okay, so our domain here in this case is going to start at 0, right? And then we're going to end at 140. That's our domain. So in order to find the domain, I just set our original equation to 0 and then solve for P. Okay, and so that's where this 0 and 140 is coming from. Okay, but in the bottom line here, the domain is going to be 0 to 140. Okay, all right. Let's look at the next part, and it's asking for the unit price. So what unit price should we use to maximize revenue? So this is going to be part C. Okay. So remember on our last example or in our last section, we talked about maximizing something. So we're going to use that same formula, right? So that same formula was X is equal to negative B over 2A. So finding the maximum value, all right, is dealing with this formula. All right. So that's why I put this in order from the highest power to the least because I knew I'm going to be using this formula. So now I can label this easily without having to worry about what was A, B, or C or anything of that nature. So this will be A, right? And then this would be B. Okay. So then we're just going to plug that information to our uh, equation here. So we're going to have negative 21,000 divided by 2 times A, which is negative 150. Okay. So when we do that, we get $70. Okay, just to save us some time. So $70, which I already have here, right? So these are the prices on your P-axis or X-axis, 0, 70, 140. So I already figured that out right there. So $70, that's where it is. Okay. So it says, okay, so for C says what unit price should we use? So we're using $70 as a unit price. And then part D says if this price is charged, what is the maximum value? Okay, so again, we're going to do exactly what we did our last example. We get for X and we're going to plug it in. In this case, our variable is P. Okay, so let's go ahead and do that. So we have D. And again, I'm trying to conserve space here. So we're going to have R of 70 equals negative 150. All right. And then 70 squared plus 21,000 times 70. Okay. All right. So if we put that in a calculator again to save us on time, we get a revenue of $735,000. Okay. So it's telling us if we sold at $70 a piece, then our maximum, okay, revenue is going to be $735,000. Okay. Okay. Now let's look at E. E is asking how many units are sold at this price? How many units are sold at this price? Well, we have our price, right? Um, when certain calculators are sold at a price P dollars per unit, the number X of calculators sold by the demand equation is this. Okay? So all we need to do is plug in um, our $70 for that. Okay? To find out how many calculators we need to sell at this price. Okay? So, all right, so that's going to be X is equal to 21,000 minus 150 times 70. Okay, so when we do that, um, we get 10,500 sold. Okay, all right. F, we're already doing F, graph R, right? And then let's go to the last one here. It says, what price should Texas Instrument charge to collect at least $675,000 in revenue? Okay, so it's talking about revenue. So that means we have a revenue equation. All we need to do is replace R of X by the revenue that they gave us. So again, they want to collect at least $675,000 in revenue. Okay, so that means we're going to replace R of X, okay, which is the Y value, by 675,000. Okay, so again, we already did F. We need to D. Okay, so we're going to do 675,000 equal that to negative 150 squared plus 21,000 P. Okay, so we're going to move everything to the left so that we have a positive leading term. So when we do that, we get, I'm going to need some space here. So I'm actually going to do this on the next page. Okay, all right. So again, we're going to move everything to the left so that I'm going to have 150 P squared minus 21,000 P and then plus 675,000. All right, so again, I'm just moving these terms to the left. And this is equal to 0. Okay, so again, this is going to be really hard to factor the way it is, so we need to factor out a term. So I noticed that 150 here can go into 21,675,000. So I'm going to pull out a 150. So we have 150 Okay. And when I pull that out, I'm gonna have p squared minus 140p plus 4500 equals 0. All right, and then I'm going to factor this. So when we factor this, we get 150 and then p minus 50 plus, not plus, times p minus 90 equals 0. Okay, all right. So 150 equals 0 doesn't mean anything, but we're going to set these other two to 0. Okay, so P is equal to 50 and P is equal to 90. All right, so what does that mean? What do these numbers mean? So it's saying that if we charge between $50 and $90, that's going to be our sweet spot where we can make at least $675,000. Okay, so if I go back here, okay. So our maximum we had was from 70 units was 735,000. So if I want 675,000, so it's going to be like right here, right? 675K. All right. So that's going to come across so that these 2 points here, okay, um, that's what we got. Okay. So, oh, let's see where to go. Over here, right? This is what we got. So P50 and P90. So this is at 50 and 90. Okay. All right. So saying if we sold between 50 and $90, then our minimum, not there, our revenue would be the $675,000. Okay. So that's how much they need to um, sell the calculators to make at least that much money.